Good morning, good evening, or good afternoon, whatever the case may be. In this video, we're going to cover section 2.3, polynomial and synthetic division. We got 3 bullet points. We'll use long division to divide polynomials by other polynomials. That'll be done in this video here, day 1. And then in the next video, we will look at synthetic division to divide a polynomial by binomials that fit this form. And then we might look at the remainder and factor theorems at the end of the section. So first, let's do a quick review here. You know, the old division algorithm, if I was dividing 5 into 7,613, I want to find a number up here that I would multiply by 5 and not go over 7. Or so how many times does 5 go into 7 without going over? It goes in once. And then when we do this, we multiply. 1 times 5 is 5. We write it down here, and we subtract. You know, there's nothing there. We could sort of distribute a negative, and 7 minus 5 is 2. We bring down the next number. How many times does 5 go into 26 without going over? Well, 5. 5 times 5 is 25. And we subtract. 26 minus 25 is 1, and we bring down the next number 1. 2 goes into 11 twice without going over. 2 times 5 is 10. And that, when we subtract here, 11 minus 10 is 1. Bring down that last number 3. 5 goes into 13 twice without going over. And then 2 times 5 again is 10. I'll write it over here, minus 10. And that's equal to 3. We have a remainder of 3, and we can write that remainder as the numerator of a fraction and divide it by our divisor, 5. And now let's take a look at what we sort of figured out here. Another way to look at this, what we figured out is 7,613 divided by 5 is 1,522 and 3/5. Or we could also now say that the number on top there, our answer, 1,522 and 3/5, times what we divided it by 5 is equal to 7,613. Okay, we just a little review here with numbers. Now let's do that with polynomials. And the book says here, consider the graph of this function, 6x cubed, 19x squared, 16x minus 4, shown over here at the right. Notice that one of the zeros is at x equals 2. This means that x minus 2 is a factor of our polynomial. And there exists a second degree polynomial, if we do the division, that the f of x would be that factor x minus 2 times, that other function. One way to find this q of x, this other function here, is to use long division. So example 1, we're going to divide this polynomial by x minus 2. So I'm going to write here x minus 2. And we're going to divide that into 6x to the third would go first, minus 19x squared, plus 16x minus 4. All right, now the goal here is to get rid of this 6x cubed, the first term, and out here we've got an x, so we need to come up with something on top here that we multiply by x and get 6x cubed, or you could go off to the side and do some scratch work. 6x cubed divided by x would be 6x squared. So that's what we want up on top, 6x squared. I'm going to write it right over my other squared term. Now imagine there's a set of parentheses here, and we're going to distribute 6x squared times x, 6x squared times the negative 2. So that'll give us 6x cubed, and then we multiply and get minus 12x squared. Now this right here, we've come to the part where most students are going to make a mistake. Don't forget we are subtracting here. So you could either say mentally in your head, 6x cubed minus 6x cubed is 0. And then negative 19x squared minus a negative 12x squared. Or I've seen a lot of students do this. Imagine there's a set of parentheses here. We're going to distribute a negative. So the negative turns this first term negative. That negative is going to make this turn to a positive. And now we can just add the columns. A little easier to add. The first column again does go to 0. And now negative 19 plus 12 is negative 7x squared. We bring down the next term, plus 16x, and we've got a new thing to get rid of. We want to get rid of now negative 7x squared. So something up top times x is negative 7x squared. Well, that's going to be minus 7x. Oops. So we distribute again this negative 7x to the x and the negative 7x to the negative 2. So that will give us the negative 7x squared that we need. And then we're going to multiply there and get a positive 14x. Now again, we subtract here, or you can distribute a negative and add. If I distribute a negative to the first term, that'll change to a plus, and then the second term will change to a minus. And now we can just add the columns. First goes to a 0. The next one, 16x minus 14x, is 2x, and we bring down the next term, minus 4. Okay, last thing to get rid of is this 2x. We've got an x out front. Let's multiply by 2, plus 2. Distribute across that binomial, 2x minus 4, and look at that, it comes out perfect. If I distribute a negative, that will change our signs here, and we can add the columns and get a 0 remainder. All right, now it says let's go back and read the directions again. Divide the polynomial by x minus 2. We did that. And now use the result to factor what remains completely. So again, let me get rid of this down here. And what we have underneath our division sign, this was our original problem. We divided out the factor x minus 2, and that left us up top 6x squared minus 7x plus 2. Now we should be able to factor the rest of this into a couple of binomials. So this binomial will stay, x minus 2. And then here, this 6x squared minus 7x plus 2 should break down farther. Now if I was any good at the ACB method, I would probably use that. But I'm just going to kind of go old school here. I notice the middle term is negative and the end term is positive, so it has to be a minus and a minus. And there's only one way to factor this 2. That has to be 2 times 1. So now it's the 6x squared that'll give us trouble. I'm going to come off over here. And what factors multiply to 6? Well, that's 1 times 6 or 2 times 3. And if we reverse that, 3 times 2, we're back to where we started. So those are our only factorizations. So I could either have a 6x and a 1x, or a 2x and a 3x, or I could reverse them. We always got to be conscious of this middle term. That's a minus 7. So what I might do is a 2 and a 3. If I try a 2x here and a 3x here, oops. Yeah, it's a little better. We just got to check that middle term by our outers and our inners. If we multiply the outers, that would be a negative 4x, negative 4, and then minus 3 more x. That would take us to negative 7. I got it right off the bat. Well, let me back up. Let's do it accidentally the wrong way first. Let's say I did not get that right off the bat. Let's say I put them in the opposite spots. Now if I multiply my outers, I get a negative 6x, and the inners would be another minus 2x. That takes me to minus 8, and that's not our middle term, so we would have to back up. And then let's go back to our original. Let's put the 2 and the 3 back where they were. Yeah, because our outers are negative 4x, the inners negative 3, and that adds up to the negative 7. So right from the get-go, if I asked you to factor this, it'd be pretty difficult. But if I give you one of the factors, x minus 2, and you divide it out, what remains might be easier to factor. So that's example 1. Okay, and here the book has a little more to say. In example 1, x minus 2 is a factor of the polynomial. And the long division process produces a remainder of 0. Often, long division will have a non-zero remainder. For example, if we divide this polynomial by x plus 1, here's our divisor, the thing outside. The dividend is under the division symbol, and our quotient is the answer on top. As we work through the process here, we do have a remainder that's not 0. So that that's going to turn into part of a fraction. That remainder is your numerator here, and your denominator is the divisor. So here's the division algorithm, and I already kind of pointed this out to you back in that initial setup when we divided just the regular numbers at the very beginning, how we're going to get two things multiplied maybe plus a remainder. So don't let all the f of x and d of x and q of x and r of x, sort of throw you. That's just our function notation. And it says up here, if f of x and d of x are polynomials, such that d of x is not 0, so we can multiply them and FOIL them out, and the degree of d of x is less than or equal to that of f of x, then there exists a unique set of polynomials q and r such that, again, this is confusing the way they have it all written out, but if we take the divisor times the quotient, if we FOIL those out, if they were binomials, and then we add in the remainder, that will equal what we started with. And of course here, that first polynomial, that r of x, or the remainder here, where the remainder is 0, or the degree of that is less than the degree of dx. If the remainder is 0, then it divides evenly, or we could say that it is a factor of that polynomial. And another way to write this division algorithm, if I just leave this here, if we divide everything by d of x. So if I put a d of x under here, it's going to cancel, leaving just the q of x. And then here is the remainder. That's going to be divided by d of x. And a lot of times our remainders will look like a fraction. And that would mean we would divide our original dividend also by d of x. If necessary, apply these steps before you apply the division algorithm. Write the terms of the dividend and divisor in descending order of power of the variable, so we got to make sure the exponents are going downhill, and insert placeholders with 0 coefficients for any missing powers. So always be conscious looking for missing exponents, and we'll see these in the next couple of examples. So example 2. Divide this, x cubed minus 1. Notice we're missing x squared and x to the first, and we're going to divide that by this x minus 1. So out here, I'll have my x minus 1. We are going to divide that into x to the third, and then we'll give a 0x squared placeholder plus a 0x to the first, and then we have a minus 1 at the end. Okay. Up on top here, I need something that's going to multiply by x and equal x to the third. Or we could say, what is x to the third divided by x? Well, we would subtract the exponents, and that would be x to the second. So if I put some blue parenthesis around here, we're going to distribute the x squared to both of those terms. So that's x to the third, and then a minus 1x squared. That's why we need that placeholder there. Now again, we can distribute a negative and add. If I distribute a negative, these signs will switch. And then we add the columns, 0x cubes, and we're going to have a 1x squared. Bring down the next term, plus 0x. So up top here, we're going to need something that will multiply by this x and equal x squared, so they will cancel each other out. Well, that's just going to be a plus x. Distribute it to both terms in the blue parenthesis, x squared minus 1x. And we can subtract or distribute a negative, and then we can add them up. That'll be a 0, and we've got a 1x minus 1, and that's exactly what we have here. So if we want to multiply by something, we have to multiply by 1. Okay, is this starting to look familiar? Remember when we factored difference of cubes? When we factored difference of cubes, like x cubed minus 1, we would bring down and make our binomial, x minus 1, and then bring over this and square it, change the sign. 1 times x is x. The last sign is always positive. Bring over the 1 and square it. And we just sort of did that in a different way. Here we did it with a long division, but we can now say the x minus 1 binomial, if we multiply it by what's on top, x squared plus x plus 1, if we, sort of FOIL this out, so to speak, we should get back to where we started, x to the third minus 1. Let's try it out. I'm going to distribute my x here using black ink, so that'll be x to the third plus x squared plus x. And I'll switch over to blue ink to distribute the negative 1 minus x squared. I'm going to put it right under this one. Minus x, might as well put it right under this one. And then minus 1. And if we add these columns, our x cubed is okay. These will cancel to 0. The x's cancel to 0, and we bring down the minus 1. X to the third minus 1. Now, if there was a remainder, we would just sort of tack that on as some numerator over the denominator x minus 1. And we could distribute this x minus 1 to wipe out that denominator, and then our numerator would be part of our answer. I think we'll see that on the next example. Didn't mean to spoil the surprise. Oh no, we got a couple practice problems for you first. Divide this polynomial by x plus 4. Use the result to factor what's left completely. And then we've got this one here. Divide, check the result. You might be missing a power of x. Be careful. So pause the video, try the problem, and then fire it back up and see if you got it right. So in this one, we're going to divide the x plus 4 binomial into 9x cubed plus 36x squared minus 49x minus 196. Ooh, this is a good one. Let's see. Our first term is 9x cubed. We've got an x, so we need to multiply by 9x squared. Distribute that. 9x cubed plus 4 times 9 is 36, x squared. Oh, look at that. When we subtract here, or if we distribute a negative and then add, we're going to get 0, 0. So we're not just going to bring down the next term. We might as well bring down the next two, because we're dividing out here by a binomial. All right, we want to get rid of negative 49x. We got to multiply x by something. It's got to be negative 49. And we distribute. Negative 49x. Negative 49 times 4 is negative 196. Well, you'll look at that. We can distribute a negative and add, and that's a 0 remainder. But we're not done. The problem's not over. Just like in the first example, use that result to factor the polynomial completely. So what we've figured out is the x plus 4 factor times this one, 9x squared minus 49. We should be able to factor it a little bit farther. And can you see what method we're going to use? 9x squared minus 49, perfect square minus another perfect square. This will be a sum and a difference. We're going to have a plus and a minus of the same terms. The square root of 9x squared is 3x. The square root of 49 is 7. So a 3x plus 7 and a 3x minus 7. All right, now for the trickier one. So here we're dividing an x minus 3. Oop, that's a terrible 3. That's a little better. Into x to the third minus 2x squared. We are missing an x, so we want a placeholder, a plus 0x, and then we'll put our minus 9 on the end there, and we should be good. So we want to get rid of x cubed. We're going to have to multiply by x squared. X squared times x is x cubed, and then we'll have a minus 3x squared. And we can subtract or distribute a negative, and now we just add. First column is 0, and then we'll have a 1x squared. Bring down the next term is 0x. We're going to have to multiply by x to the binomial, so that'll be x squared minus 3x. Distribute a negative, and then add. So now we got 3x minus 9. Ooh, and this looks good. We need to get rid of 3x, and we've got an x here, so we're going to multiply by 3. And if we distribute that 3, we get 3x minus 9. And no remainder on that one, it looks like. Okay, I was expecting a remainder, but it does say, oops, check the result. So what we want to do is sort of FOIL this back out and make sure we get back to the original problem. So we've got x minus 3, and we're going to multiply that by x squared plus x plus 3. And let me move this up a little. Okay, and I'll color code this. Black ink here. So we multiply there and get x to the third plus x squared plus 3x. And then I'll come underneath, use blue ink, negative 3 to the x squared. That's negative 3x squared. Negative 3x and minus 9. If we add up our like terms here, the first column, we still get the x to the third. There, x squared minus 3x squared is minus 2x squared. 3x and negative 3x cancel, and then we've got this minus 9. And that is exactly where this problem began, right here. So it looks like we did it. One more here. I think this is the last example. Yeah. Divide this big polynomial by this one. Holy cow, this one looks complicated. Let's start here. We're dividing this into it. So this is our first three-termer. And let's write it in descending order. The x squared will go first, a plus 2x in the middle, and a minus 3. We are going to divide that into, now this, it's all out of order, and there might be a missing term in there. Let's be extra careful. Our biggest exponent is 2x to the fourth. So plus 2x to the fourth. Then we got an x to the third plus 4x to the third. 0 squared minus 5x squared. A plus 3x and a minus 2. Plus 3, ooh, that's a bad 3. Plus 3x minus 2. All right, looks like we got our work cut out for us, but we should be all right. So the first thing to get rid of, and let's do three terms here, because we've got a three-termer we're dividing in. The lead over here is a 2x to the fourth, and I've got an x squared, so that's got to be a 2x squared. And I'm going to put that here right above the x squared below it. And remember, here we're distributing, so we are going to have three terms. 2x squared to the x squared, and then to the 2x, and then to the negative 3. So let's distribute there. We're going to have a 2x to the fourth, and then a plus 4x cubed, and then a minus 6x squared. Let's distribute a negative here, so that'll switch this to a minus, and this will change to a plus, and we can add the columns. 0, 0, and then we'll have a 1x squared. And let's bring down the next two terms, because we are dividing by a trinomial here. And we've got an x squared, and we want to get rid of it, so we're just going to multiply by 1. Plus 1. And if we distribute, that will be x squared. Ooh, that's a terrible exponent, x squared, plus 2x, and then minus 3. And if we distribute a negative here, first term is negative, middle term is negative, last term will be positive. Let's add this up. 0, and then we'll have a 1x and a plus 1. So here we have a remainder. And let me, well, I guess I can come up here. I'll put a plus, and we'll make a little dividing or a fraction line. Our remainder is the numerator, x plus 1. Our denominator is what we were dividing into here. This x squared plus 2x minus 3. Let me see if I can squeeze it in here. X squared plus 2x minus 3. Now that's not too good. Let me do this, because we are going to check our result. So we are going to have this x squared plus 2x minus 3. If we multiply that by what we have up here, multiply that by 2x squared plus 1 plus our remainder, x plus 1, over, now I have room to write it, x squared plus 2x minus 3. Now, let me just erase a little more, get some more room here. Now, the big picture, what's going to happen, we are going to sort of FOIL and distribute this binomial and this trinomial. So, we'll be foiling these out. But when it comes to this remainder, back up. There it is. When it comes to the remainder, we're going to distribute this entire trinomial to this term because it's got its own plus sign. That's going to wipe out this denominator, and our answer will just be the x plus 1 for that piece. So let's back this up. Okay, I'll start with blue ink. I'll do the x squared to the 2x squared, so that's 2x cubed, or 2x to the fourth. X squared to the 1 will be a plus x squared, and I'm going to leave a little gap in there, plus x squared. Now we'll distribute this 2x. 2x to 2x squared is 4x cubed. I might as well put that here. 4x cubed. And then the 2x to the 1 will be a plus 2x. And now finally we distribute this negative 3. Negative 3 to 2x squared is minus 6x squared. I'll put that under the other x squared. And then the minus 3 to the 1, that will be a minus 3. Now we are going to distribute this entire divisor to the second term, where it's going to just wipe out this denominator. So we are going to have a plus x plus 1. I'm going to put my plus x under this one, and my plus 1 will be paired up with that 3. And let's see, I hope I did everything right. If we add this column, 2x to the fourth, and back up in the original, there's that 2x to the fourth. Let me clear some of this out. So we've eliminated 2x to the fourth. We got that term. Plus, the next column is just a 4x to the third. That was in our original right there. If we add these next two terms together, a minus 5x squared, that was right here at the beginning. The middle here, the 2x and the x, that'll be a 3x. We had that. And then the minus 3 and the plus 1 is minus 2, and we got it. Perfect. Sometimes the checking is harder than the actual division. Okay. One more for you to try on your own, and then your assignment for this will be on WebAssign. Enjoy. So pause the video, try this practice problem, and see if you got it right. Okay, we're dividing 1 plus 3x. I'm going to write that in descending order. 3x plus 1. We will divide that into, here we got to put it in order. It looks like our highest power is 6x to the fourth. And we've got a minus x cubed minus x squared plus 9x and a minus 3 on the end. Let's see what we can do here. So we want to get rid of 6x to the fourth. We've got a 3x. So you could think, okay, 6 divided by 3, well, that's going to be a 2. X to the fourth over x, well, that's x cubed. So we're going to multiply by 2x cubed. Distribute to both of these terms, 6x to the fourth plus 2x cubed. And we either subtract or distribute a negative and then add them together. Negative 1x cubed minus 2x cubed is minus 3x cubed. And we bring down a minus x squared. All right, let's get rid of minus 3x cubed. We've got a 3x, so we need a minus x squared. Distribute the negative x squared, and we get negative 3x cubed minus x squared. Oh, and if we distribute a negative here, boom, boom, that turns into a 0. So we bring down the next two terms, bring down the 9x and the minus 3. And let's see here, we want to get rid of 9x. We're multiplying by 3x, so we need another 3x. 3x. Multiply, oh, no, just a 3. 3x, we need just a 3. 3 times 3x is 9x. 3 times plus 1 is plus 3. Ooh, now it almost looked like a no remainder, but if we distribute a negative, this will add to 0. Distribute the negative here, now it's going to add up to negative 6. So we could write plus a negative 6, or more simply, just a minus, oh no, let's do it the other way, plus a negative 6 over our 3x plus 1. All right, let's see if we did everything right when we check it. So here is our 3x plus 1. And we're going to multiply that out with 2x cubed minus x squared plus 3. And we can make this its own separate term, plus a negative 6 over that 3x plus 1. So again, at the end, we're going to distribute here to the first term and sort of FOIL that out. But we are going to distribute this to here, which will wipe out the denominator. And then the negative 6 will sort of just fall down and jump into the problem. And I guess I can erase this because we can compare my answer with our original right there. Okay. 3x times 2x cubed, that will be 6x to the fourth. Distribute here, that will be what, minus 3x cubed. 3x times 3 is a plus 9x. I'm going to leave a little gap in there in case I have another term appear. And then we distribute the 1. 1 times 2x cubed is 2x cubed. 1 times negative x minus x squared. So I'm going to put minus x squared there. And then a plus 3. Put that out here. And when we distribute, again, this entire term, to here it wipes out that denominator, so we're also going to tack on there a minus 6. I hope I did everything right. Add our columns, we get 6x to the fourth, 6x to the fourth. We got a minus 3 and a plus 2, so that'll be a minus x cubed. Ooh, and that matches up right there. Next column is just a negative x squared. We've got one of those. This column, there's only a 9x plus 9x, and that's right here. And then a negative 6 and a plus 3 is minus 3. Boom goes the dynamite. We got it. Nice, and it even checked out. All right, so enjoy the homework, and I will see you in the next video.